So what we're getting into now is that we're going to graph the trig functions, so drawing graphs on them. You are just going to learn a new shape. You know how the quadratics are a U shape, and the cubic is the wiggle shape, and the absolute value is the V shape? Same thing, we're just gonna do the trig one, so it's nothing to like be nervous about, all right? We're gonna do this little exploration for sine. What I want you to do is off to the side, draw yourself a unit circle, and we're gonna label the up, down, left, right, like the compass point ones, okay? So what is our coordinate for 0 pi? If you have not rotated anywhere, what is that point? Oops, we forgot already. Thank you, Hunter. 1, 0. How about the one at the top? Good, and how much rotation is that? We are done with degrees. You are never going to see them again. Ever, 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 ever. 1/2 pi. Pi over 2. Very good. All right, and then what is this coordinate? -1, 0, and how much rotation is that? Pi. And then down here is 3 pi over 2, and that is 0, -1. So those are your quadrant angles, the ones that are on the axes. All right. So when we go around and do these, sine is the X or the Y? Do we remember that? Sine is the Y value. So we're going to go around our circle and grab all the Y values. This is like I was just saying, that test I just passed back, you're not allowed to forget that stuff. This is going to build on that. That's our foundation, all right? So at 0 pi, that's right here where I'm pointing. Sine is the Y value. What's the Y value of this point? 0. Very good. At pi over 2, that's up here where I'm pointing. What is the Y value? 1. At pi, which is right here where I am pointing, what is the Y value? 0. Down here at 3 pi over 2, what is our Y value? -1. And if you make it all the way back to 2 pi, 0. So that's the same as at 0 pi because they're coterminal angles. You ended up where you started. Are we all still together? We're all on board? Y values, because it's sine. All right. Now we're going to go backwards. If you rotate backwards pi over 2, where is that going to put you? Down here at the bottom, what's the Y value? -1. Negative pi, you rotate negative pi, that actually puts you at the same place as positive pi. What's the Y value there? 0. -3 pi over 2. Watch me point to this. You start here. You always start right there. If you go backwards 3 pi over 2, you're going to be up here at the top. So what's the Y value? 1. And -2 pi is the same place as +2 pi. It puts you right back where you started, which is 0. Do you see how they're all zeros and ones and -1s? It's like we're speaking binary. All right. Now what you're going to do is take those points and put them on your grid. Do you see right here how you have 0, 0, 0 pi, 0? All right. So that's going to start you right here. So like the origin. Sorry, I'm going to have to keep moving the paper up and down to do this. At pi over 2, do you see how we got 1? Right, so pi over 2, 1. And then at pi, we got 0. Do you see that there? And then what was it for 3 pi over 2? -1. And then 2 pi puts you back to 0. And then you can go ahead and keep the pattern going. Once you get a little bit of it started, could you keep this going? Like, do you see how it's going to be a wave? All right. So what I want you to do is fill it in for the whole space that you have. And when you connect it, I'm not here to grade your art skills. However, you need to make an attempt to make it be a nice, smooth curve. It shouldn't look like a jack-o'-lantern mouse. You know what I'm saying? Like, it shouldn't be all jaggedy. And also, do not put arrows on the ends. And this is why. If I stuck an arrow on the end of this, an arrow indicates that it's going to keep going the same direction forever and ever and ever and ever and ever. That's not what this is going to do. What is it going to keep doing? Yeah, it's gonna keep waving. Has anyone taken, is it chemistry where you do the sound waves? Or physics? You might do it in physics too, like sound waves. Okay, it's like, I don't know what it is. All right, so some things that we notice. I'm gonna draw your attention to some stuff. What is our domain? Left to right. Yeah, all reals. It's gonna be everything, right? It's gonna go left and right forever. There aren't any holes. There aren't any asymptotes. It's a lovely little wave. All right, how about the range? Because that will not be all reals. If you sweep downwards to upwards, what's it gonna be? Good. -1 to 1, brackets or parentheses? Good. Brackets because there are actual points there at -1 and 1. You get to include those. All right, the function is continuous, which means you can trace it without lifting your pencil off the paper. There aren't any holes or asymptotes or gaps or breaks and all of that. This is going to come up later on in the future, which is why I'm bringing it up now. This is an odd function. We did cover even and odd functions, but it was back in the first quarter, so I don't truly expect you to remember that, but it was about the symmetry. Odd means that it is symmetric to the origin. So it has symmetry to the origin. Even functions were symmetric to the y-axis, like a quadratic that hasn't been shifted, symmetric to the y-axis. Do you see how this is symmetric to the origin though? Can you watch me point to it? Like this part gets reflected down here. See what I'm saying? It's going to be important later, is why I'm bringing it up now. Y-intercept. What is our y-intercept for this one? 0, 0. The reason I bring that up is because if you remember where it starts, then you can get the rest of it. If you have that starting point and then make it wave. And then we do what is called the period of the function. And that's how far it takes to complete one full cycle. So I'm going to highlight it on mine. You don't have to, but I'm just trying to illustrate it for you. Can you watch? We start here at 0. Do you see how it goes up, goes down, and comes back to where it started? Do you see how that's one full cycle? That is what distance on the graph? Oh my gosh, it's 2 pi. Isn't that crazy? Why does 2 pi make sense? That the period is one way around the circle. So that is one full rotation of the graph. And when you graph these, the directions are going to show 2 periods of the function. So you need to go far enough to show at least 2, to show you can continue the pattern. So here's what I'm going to do. I'm going to pause this recording and I want you to try and do this one for cosine. It's going to be the exact same thing, except for sine, we did the y values when we went and got all these points. For cosine, it's going to be what? All the x values. Cosine is all your x values. Are you guys even filling in the stuff at the bottom? Oh, wow. Oh, okay. Above and beyond. I kind of just expected you to get the graph. Can I slow you guys down then? I want to make sure you all got the same thing as me here to make sure your graph is right. Oh, sorry. That happens to me all the time because I can see it. I know it's like a poor excuse, but that's my excuse. I can see it. All right, can you please make sure that yours matches mine? It should look exactly like the sine graph, except what do you notice is one difference, like how you could tell the difference between them. Yeah, and that's why I bring that up. So if you can get the starting point, and then make it wave, then you can fill in the rest of it. So let's do the same things that we did on the other side of the paper. What's our domain? Good. And that's like an automatic answer for sine and cosine. We're eventually going to do all 6. Today we're just doing sine and cosine, but like that is the answer for sine and cosine. Range, again, you are stuck between -1 and 1. This one is also continuous. You're probably like, why is she bringing that up? They're not all continuous. Do you remember last unit where sometimes you got an answer of undefined? Let's real quick have a conversation about that. When there's an answer of undefined, what does that mean you would have in the graph? An asymptote. So like, that's why I'm bringing up these ones are continuous because they all aren't. And I want you to be able to compare and contrast them. All right, so this one, look at, do you see how there's symmetry to the y-axis? Like I could fold this over here and it would match up. So cosine is an even function. So that means symmetric to the y-axis. And again, I'm bringing that up because it is important later. It'll be a ways from now, but I like to just bring it up now, and then later on I can be like, hey, remember I said that thing? And you either will or won't, and I'll explain it again. Okay, even function. Your y-intercept is 0, 1. So again, if you can remember where it starts, then you can usually get the rest of it. And then the period, again, how long it takes to complete one full cycle. So watch me do this one. I'm just going to highlight it. So we start here at 0. It goes all the way down here and then comes back up. It's when you get back to where you started. So this portion of it. So again, that is how far, which should make sense because that's once around the unit circle. So again, for today, we're just going to do sine and cosine, but I'm going to write this out the way that it'll look for all 6 of the trig functions so that you can apply it to any of them. In a way, I'm almost teaching you the entire unit today because what we're going to do is sine and cosine. You're going to apply the exact same process to all the other 4. So it's not really going to be very much different, all right? So your function y equals, and this is going to look like the alphabet threw up on your paper. So you're going to have to trust the process a little bit and I'll see you through it. All right. So we're going to have A as that coefficient that sits out front. And then what I do is I write trig. What's going to be written there is sine, cosine, tangent, cosecant, secant, cotangent, but it could be any one of the 6. So for just the like in general format, I just write trig. Does that make sense? Like it could be, okay, perfect. Bracket, and then you're going to have B parentheses, x minus c, no, close the bracket, and then plus d. And we're going to talk about what A, B, C, and D do. Do not get bent out of shape over this because you've actually done this before. Do you remember stretches and shrinks and reflections and shifting left and right? Same exact thing, okay? This is just the format that we write it in. Bless you. The amplitude is your vertical stretch or shrink. That's going to come from the A value. It's not negative though. So what we do is we absolute value the A. So just don't put a negative with it. And so that is your vertical stretch or shrink. And as a heads up, because again, we're only doing sine and cosine today, but we're going to do the other ones. The amplitude is only for sine and cosine. By definition, an amplitude is only for a wave. And those are the only 2 that are a wave. We'll learn the other shapes later, but the other ones just don't have one. Like you just say none. It's by definition, an amplitude is only for a wave, right? The phase shift comes from C. Do you see how that would be the left or right motion? We now call that phase shift. Again, it's not any different. We're just giving it new vocabulary, all right? So the phase shift is the C value. That's how much you moved left or right. I'm going to go over to the vertical translation next. If phase shift is your left-right motion, vertical translation is up or down. Which letter A, B, C, or D is going to move it up or down? Yeah, D, that one that's tacked on at the end. So that's D. That's how much it moves your graph up or down. How much it shifts it vertically, your vertical translation. So those are all things we've done before. The period is how much it takes to do one full cycle. What did we say it was for the parent functions, the ones that hadn't been shifted at all? So what you're going to do is take 2 pi over your B value. Do you see how that would be the horizontal stretch or shrink in there? Again, it can't be negative, so we put an absolute value around that. Just don't put a negative with it, is all that is. But that is your horizontal stretch or shrink. I'm trying to relate this to what you've done before because it's not any different. We're just using new words for it. You're like learning new vocabulary is what it is. All right, and for the range, I'm gonna draw a little picture. So if I dot in how much you moved up or down, that would be your D value. That's how much you moved up or down. Here's your wave. All right, come with me on this. This distance is your amplitude. Do you get what I'm saying about the wave? That distance is your amplitude. We said that was A. So how would you get your range? The low value to the high value. If D is the center and A is how far away you get from the center, how could you get your range? Well, how could I get the low value? Let me say that. How could I get this value that's down here? You have to subtract, right? It would be D minus A. Good. So it would be D minus A. And then how would you get that maximum value? Get D plus A. So it's the center plus and minus your amplitude. You can always just wait until you get the picture and then count the little boxes, though, you know, whatever. All right, so let's go ahead and fill everything in for this one and get ourselves a graph. What is your domain for sine and cosine? Since it's a wave and it goes left and right forever, yeah, negative infinity, positive infinity. That is the answer. I'll wait until we get the picture to do the range because that seemed that kind of threw you guys off, so we'll hold off on that. Amplitude. What do you guys think? It's your vertical stretch or shrink. 3. Now it is just 3. I'm going to go ahead and write absolute value of 3 and then equals 3 because what happens is when there's a negative there, people will put a negative number. I'm just trying to remind you that it's positive, right? Period. It's going to be 2 pi over whatever's in front of the x. And you're going to hear me say that 4 billion times. It's 2 pi over whatever's in front of x, this b value. Hey guys, look right here where I'm pointing. What's in front of x? Good. It's really a 1. So if you put 2 pi over 1, is that going to change anything? No, it's just 2 pi. And what that means is it did not get stretched or shrunk. It stayed the same, which is good. All right, phase shift is your left or right. I usually put a box around this part as well to like separate that from everything. Do you have a shift left or right inside of there? No. So you can say 0 or none, however you want to put that. And then there is a vertical translation. What's our vertical translation? Yeah, now you can either write -4 or you can write down DOWN 4, however you want to say that. Like, because writing it in words is how we did it before. But if you just want to say -4, you can do that. All right, now when we go to fill in our table, you're going to start with your phase shift. Whatever your phase shift is going to go in that first box. And what you're doing is you're shifting to where the new start is. That's your left-right shift. Do you remember when we would make table of values and I would say, like, go to wherever the new center is? It's what we're doing. Same exact thing, right? It's not any different. So what was the phase shift for this one? There wasn't one, right? 0. And I tend to write 0 pi. I like putting the pi in there. You don't have to. That's a personal preference. And then what you want to do is 1 full cycle. So you want to add the period of the function. You want to do 1 full cycle. So what we say was the period of this function? 2 pi. All right, hey guys, 0 pi, that's where we're starting, plus 2 pi will give you 2 pi. And then you're going to break it down to what's halfway in between. This sometimes ends up being fun with fractions, although I started with an easy one. What's halfway in between 0 pi and 2 pi? Yeah, 1 pi. And then halfway between 0 and 1 is a half. And so you're counting by halves. This is 1 half, 2 halves. This one would be 3 halves. You're just counting by fractions. That's like fun with fractions there. Are we all still on board? Okay. I put the unit circle on the sticky note as well so that I could pull it out and view this. This one is sine. Is that your x value or your y value? That's your y value. So what you're going to do is go around to your unit circle You're gonna have to watch me point to it. You're gonna get all your y values, multiply them by 3. You guys okay? I know, we gotta get through this though. Multiply them by 3 and then subtract 4. Okay, and they're all gonna be zeros and ones, so it's real easy. What's your first y value? We're gonna start right here. 0 times 3 is 0 minus 4, -4. Good job. Now we just have to keep going around the circle. Now go up to the top. What's your y value? 1 times 3 is 3 minus 4, -1. What's the next one? 0, which is going to give you -4. Now we're down here at the bottom. Do you see how we're just venturing around the circle? All right, what's your y value? -1 times 3 is -3 minus 4, -7. And then the last one is always going to be the same as the first one because it's going to put you back where you started, right? Now we're going to draw it. You have to label your tick marks. And do you see how these counted by halves? So you would want to do pi over 2 pi, 3 pi over 2, 2 pi. I don't recommend doing that though. They're going to be this tiny and it's going to be impossible to see them. So here's what I would do. If you want to count by halves, skip 1, that would be a half, and then just call this one pi. And then skip another one, and then the next one's 2 pi. And then skip another one, and the next one's 3 pi. Are you following me? Like, just you don't have to write all of them. All right. And in fact, that's enough. I don't need more than, let's label 3 tick marks. That's good enough. Because now you know what they are. And then you're going to plot the stuff, right? We have to go all the way down to -7. That's going to be like way off this grid. So can I make the suggestion that we like count halfway in between those? Do you get what I'm saying? So we have to go down to -7. It's going to be way off the grid unless we do that. All right, so 0, -4, 1, 2, 3, 4, that'll be right there. And then pi over 2 gives you -1, that would be right about there. And then back to -4, and then down to -7. And then back to -4. So that is one period of the function. You need to show 2. So what I need for you to do is continue that pattern until you've done it once more. Do you get what I'm saying? Like, I'm just checking that you can continue the pattern. So could you keep that pattern going? Like for one more? So it should look like that. So a total of 9 points. I guess if you're counting points, a total of 9 points, but 2 full cycles of the thing. And I didn't fill in the range because it seemed like you guys were sort of struggling with that when I did it, like the in general one. You can always just wait until you get the picture and then look at it. Hey guys, what 2 y values are we caught in between for this one? Yep, good. It'll be bracket -7 to -1. So if you kind of think about where the center is going to be and then add and subtract the amplitude, you can figure that out, or you can just wait until you get the picture. The only thing with waiting until the end is don't forget to do it. Like if you turn your paper in with it blank, I can't help you out there. All right, let's try it again. We'll do one more and then I'll give you another break. You guys are really fading here today. All right, what is our domain? Everything, all reals. I'll try and speed this one up now that we've got the hang of it. Amplitude. What's in front of this? It's really a -1, but you have to absolute value that, so it would be just 1. All right, the period, it's 2 pi over whatever's in front of the x. So what is in front of the x? You guys see this here? 1/2. Now, dividing by a half is the same as multiplying by 2. For example, dividing by a third is the same as multiplying by 3. Okay, so what would that give you? 4 pi. I wish I could have had the slinky out here. Use your imagination. Pretend I'm holding a slinky. Instead of 2 pi, we stretched it and now it's 4 pi. See what I'm saying? Horizontal stretch is what we did there. Phase shift is your left or right. So did this count it backwards? Did it move left or right? Which way?
Left.
Kind of backwards. It went right pi. So you can either just say pi, or you can write out right, R-I-G-H-T, pi. But if you say positive pi, that's good enough. If it went left, you could say negative pi. And then did we have a vertical translation? Like, did it shift up or down? No. So you can say 0 or none. There's not a number added at the end. All right, you're going to start with your phase shift. You're shifting to where the new beginning is. So what was our phase shift? Phase shift is pi, 1 pi. And then you add the period. You want to do one full cycle. So what was our period? 4 pi. So 1 pi plus 4 pi is 5 pi. And then you have to break that down to what's halfway in between. But I think this one you can just count by pi's, right? Like 2 pi, 3 pi, 4 pi. Let me get out my sticky note. You want to box off the part that is the trig function and what's inside of it. The only stuff that should stay outside is whatever's out front, in this case, a negative, and then whatever's added or subtracted at the end, in this case, nothing, all right? So we're gonna go around our circle and just negate all the values. Do you see that? Do you see how the rest of the stuff is inside? That gets boxed in with it, all right? What's your first y value? 0 times a negative, still 0. All right, going around the circle. Now we're up here. Your y value is 1, but it's going to be negative 1. Could you keep the pattern going? What's the next one going to be? 0, and then positive 1, and then 0, and then negative 1, and then 0, and then positive 1, and then 0. I'm not trying to torture you, but I have to explain it slowly until you get the hang of it, and then you can kind of just keep it going. All right, now labeling your tick marks. So you can call this 1 pi, 2 pi, 3 pi, 4 pi. I would maybe skip every other one again, because then you just have to write so small. So each tick mark is 1 pi. It's just that I like only wrote 2, 4, and 6 to make it fit because they're so tiny. All right, so pi is 0. That's going to be right here. And then negative 1, and then 0, and then positive 1, and then 0. It's going to look like this. Do you see how it's upside down? That's because of the negative. Do you guys notice that? How it went down first instead of up first? Okay, so making sure. All right, and then I just need you to continue that for one more cycle. So a total of 9 points, but just do that one more time. I get some people that are purists and like want to fill in the whole thing. You can do that if you want. It's not necessary. This is the amount that you need to show, is 2 cycles. All right, so these ones, same exact process, but since it says cosine, what is the only thing we're going to do different? X values. Perfect. All right, so domain will be everything. Let's see. What else do you guys know? What else could we fill in? I don't really care what order we do it in. What do you think? Good. That's negative 1, or you could write down 1 if you want to still write it in words like we have before. Cool. What else? Good. What's our phase shift? Which direction did it go? Left. So it would be negative 1/2. Or you could say left 1/2. Sorry, you were talking so quiet, I just couldn't hear you. Confidence. All right, what else could we fill in? All right, period is, how do you get that? Flip over if you don't remember. All right, 2 pi over b, which is whatever's in front of the x, which in this case, weirdly, is 2 pi. So what's 2 pi over 2 pi? 1. The pi's canceled out. That means in your table, you will have no pi. Pi's are gone. Oh, today is Pi Day as well, so happy Pi Day. All right, amplitude, a little tricky because there's nothing written there, but what's in front of this? 1, and it's the absolute value of 1, which is this one. We'll wait on the range. right? But just don't forget to go back and do it. So what goes in the first little box? Do you remember which one of these numbers we start with? Good, -1/2, because it's your phase shift. You go to wherever you shifted to, and then you add the period because you want to do one cycle. So -1/2 plus 1 is +1/2. And then you kind of just have to break it down to what's halfway in between. That one's not too bad though. What's halfway in between -1/2 and +1/2? Yeah, 0. And then what's halfway in between 0 and 1/2? 1/4. Good. So that's 1/4 and that's -1/4. What's cool though is it doesn't even matter what that says. You're gonna just go around your unit circle. Like if you get that wrong, you can still get the other half of it right. So what I like to do is box in the trig function and everything inside of it. The only stuff that should be outside is if there's a coefficient, which in this case there's not, or it's just 1, and whatever you added or subtracted. So we're going to go around our unit circle. We're going to use our x values and we're going to subtract 1. So here's the beginning. What's your first x value? 1 minus 1, 0. Then you go up to the top, your x value 0 minus 1, -1. Now we're over here. Our x value is -1 minus 1, -2. Could you keep it going? What's the next one going to be? Yeah. -1 and then 0. You will always end where you started. These two numbers should match. Now, when you go to label your tick marks, do you see how we're going to have to count by fourths? Here's my suggestion. Watch me do this. I'm going to go to the 4th little tick mark and just call that 1. And then if you go 4 more and call that 2, then I know each one of them is a 4th. You don't have to write 1/4, 2/4, 3/4. Like you can just do that. And then I'm going to go this way a little bit and call this -1. And then this one -2. You don't have to label them all. In fact, I suggest you don't because it'll be super tiny. You won't even be able to see it. And then you're just going to plot those. That's all. -1/2, 0 would be right here. And then -1/4, -1, 0, -2. I'm not going to read them all to you because that's annoying. Just go ahead and plot your points. So that is one period of the function. That's one cycle. I need for you to continue it for at least one more. So go ahead and just keep the pattern going until you get back where you started. You can, of course, do more, but that's the bare minimum. And don't forget to go back and do the range. So what two numbers are we stuck between here? Yep, good. So it'll be bracket -2 to 0. Just don't forget to do downwards to upwards. Like it has to be the smaller one to the bigger one. Like if you write 0, -2, I have to take off for that. So just be careful. All right, we'll do one more. We'll do number 4. I feel like we're getting the hang of it. All right, domain, everything. All right, what's our amplitude for this one? 1/2. And I am going to just write absolute value of 1/2 and then equals 1/2 just to remind you because people will forget to make it positive. If you don't want to write that, fine. Just don't forget it has to be positive. All right, the period would be 2 pi over whatever's in front of the x. So what's in front of the x? Just 1, which means that didn't change, which means there's not a horizontal stretch or shrink. It just stayed the same, which is good. It's a good thing. All right, there is a phase shift though. What is our phase shift? Yeah, good. Or you could say left pi over 4. Went to the left pi over 4. So that's what's going to start our table if you want to even just go ahead and put that there. Like these are going to match. And then vertical translation. None or 0. Either one, doesn't matter. All right, so we start with whatever the phase shift is. You're shifting to where the new center is, and then you have to add the period. All right, this one's going to be a little bit more fun with the fractions. We have -1/4 And then we have to add 2. I'm just gonna write off to the side here, negative a fourth. How many fourths is 2? 8. So if you put that together, 7, good, perfect, 7 fourths. Together so far? Now you have to break it down to what's halfway in between. Here's my suggestion. Ignore the pi and ignore the fourths. You just need what's halfway between -1 and 7. And to be really honest, I'll do this sometimes for people that have trouble counting it out. Just trust me, it'll work. Do you see how I made a number line from -1 to 7? And then you can just count to the middle. Do you get what I'm saying? Like, it'll work. All right, so what's halfway in between if we count this to the center? 3. So 3 pi over 4. And then halfway in between -1 and 3 is 1, so 1 pi over 4. And then halfway in between 3 and 7, 5, so 5 pi over 4. Make a number line, it'll work. And then you can just count, like leapfrog your way to the center. At the end of the day, though, if you can't get that, make something up. You can still get the other half of this without it, because you're going to just go around your circle. And what are we going to do to the numbers from our unit circle? Once we get them from here, we have to times them by a half. And then there's nothing added at the end. So you're just going to times them by a half. All right, what's your first x value? Oh, I should have asked you. Are we using x or y values? X, because it's cosine. All right, what's your first x number? 1 times a half, the half. Then we're venturing around the circle. The next x value is 0 times a half. 0. What's the next one going to be? Negative a half. And then 0, and then 1/2 back where you started. You will always start and end at the same spot. From there, you just have to plot all of that. Do you see how these are all fourths? It means you want your tick marks to be fourths, but here's my suggestion. Just go to the 4th one and call it pi. Then you can go to the 8th one and call that 2 pi. You don't have to label every single one. In fact, I think that's a bad idea. Let's say label at least 3 though. 3 is a good number. We'll go with that. All right, and then just go ahead and plot them. Negative a fourth, you get a half, which is right there. Just put your point like floating halfway in between. Pi over 4, 0 would be right there. And then 3 pi over 4, -1 would be right about there. Then 5/4, 0, and 7/4, a half. I'm gonna fill this in for the first period of the function. And then can you guys watch me point to this? I know you're all busy drawing it too, but you have to do one more cycle. Do you see how we skipped every other tick mark when we plotted our points? You see that? You have to continue that pattern when you go to do one more cycle. So my next point is going to be right here. Like you have to skip one. Do you see how we did every other one? If you don't, your graph is going to look wonky. Like there won't be symmetry to it. So like you will notice if you mess it up. Do you get what I'm saying? Like it'll be uneven. You'll look at it and go, hey, that's wrong. Mine got a little weird there. And then just don't forget to go back and do the rate. And do you see how like narrow that graph is? Because we did a vertical shrink by a half. Do you see how it got squished? It's shorter, like an elephant sat on it. All right, so what's our range gonna be? Brackets and then what? Negative a half, positive a half.